Good morning, children. How are you all? I hope you are fine. I'm very happy to meet you by sharing this lesson. This lesson name is Atomic Structure. We have been discussing with a series of videos about the concept of atomic structure actually. As we know, we have studied so many videos. We discussed it, we shared. Thank you for your appreciation and applause. Today we are going to learn another topic that is a very revolutionary topic which I want to expose you. The topic name is electrical discharge through gases. The point is, why do we learn this electric discharge concept? Because we have a speculation actually, atom is indivisible. So we have a speculation, atom is indivisible. From 5th BC till 1800 AD, we stick on to the idea. Those are philosophical speculations simply. But these are ruled out because of this experiment. Such a way, this is highly important and plays an exceeding prominent role in this lesson. So this is a very special topic today. Now, what is electric discharge actually? Electric discharge, it is a natural phenomenon actually. It's a natural phenomenon where the formation of lightning when the lower parts of the cloud and when the upper part of the earth, when they are coming together, close together, they are lightning formed. Lightning is a natural phenomenon which always we observed in a special cases actually. And the thunderbolt, lightning, all these things are the natural phenomenon. In our 8th class state syllabus, we learned it. Now, so the lightning is formation of lightning. It is nothing but the concept of electric discharge. What is the meaning of electric discharge actually? Electric discharge means electrical conductivity. Electric discharge through gases means electrical conductivity through gases. As we all know, materials are divided into three types. One is conductors, insulators. In between conductors and insulators, we can call it as semiconductors. Conductors, the particles are the matter, are the material which allows the current through itself. It is called as a conductor. If any matter which does not flow the current through itself is called as dielectric or an insulator. So my point is here, solid materials, they exhibit conductivity. Liquid materials, some of the liquid materials, some of the solid materials, they allow the current through itself. What about the gases? Does gas conduct electricity? Simply we can say no. Why? Gases are insulators in normal temperature pressure. In normal temperature pressure, gases are acting as dielectrics. They do not pass the current through itself. Why? The reason is because there is no availability of free electrons. So that what happened means till 18th century we cannot discuss any kind of information about the divisibility or indivisibility of atom. We stick on to the indivisibility of atom. When William Crookes discovered discharge tube, I want to show you the discharge tube on this diagram actually. Discharge tube, it is a cylindrical glass tube actually. The cylindrical glass tube is connected with, two electrodes and attached with vacuum pump with manometer. Dear children, look at this one. Why do we use discharge tube? Because we want to apply some special conditions in order to make the gas into a conductor position or exhibit conductivity. So my point is here, just I want to explain to you today. This discharge tube contains cylindrical gas, two electrodes, cathode and anode, and high potential battery, and also vacuum pump which helps to lower the pressure, reduce the pressure or decrease the pressure. By decreasing of the pressure, already I said to you, I told you that is, gases are insulators. They do not pass the current through itself at normal temperature pressure. Simply we can say normal pressure means atmospheric pressure. Atmospheric pressure means 76 centimeters of Hg or 760 mm of Hg. In 760 mm of Hg, all the gases are as insulators, behaves like insulators. But when we reduce the pressure, when we decrease the pressure, and when we raise the potential difference, see, two conditions we have to apply. The first condition is we have to reduce the pressure, and second condition is we have to increase the potential difference. So when we apply these two conditions, the first condition is reducing pressure up to from 760 mm of Hg to till 0.001 mm of Hg. How is it possible? By LPG, lower pressure gas pump, which we can call it as a vacuum pump. By vacuum pump we can adjust the pressure so that, see, for example, from, I want to give you some details, just I want to read for you. Look at this please. From 2 mm of Hg in a discharge tube, Faraday's dark space is formed. Before that also Aston's space also formed. The luminous glow at cathode actually. Remaining space is dark space. At 0.4 mm of Hg, Crookes dark space is formed. I will give you the photos for better understanding actually. The striations are formed in 0.4 mm of Hg. At 0.01 mm of Hg, Faraday dark space is disappeared, filled with Crookes dark space. At 0.001 mm of Hg, what happened means invisible rays are emitted from an electrode which is called cathode. From cathode, some of the rays are released. That rays which are invisible, but when strikes the cylindrical glass, which edge is made up of simply coated with zinc sulfide screen, when it strikes the zinc sulfide screen, it gives out some sort of radiation or lightning or a brightness. As scintillations we can say. As a result we can say some of the invisible rays are flowing from cathode electrode to anode electrode. See, listen to my word very carefully. Why? What happened to that one? When we reduce the pressure, increase the potential difference till 10 kilovolts or 10,000 volts, what happened means ionization of gas is formed. So gas will become ionized, and thermionic emission, as we all know that, because of the passing the electric current potential difference, what happened means cathode electrode which release or gives out one electron, loses one electron. That simply at the time we don't know that is an electron, but whereas we come to conclude there are invisible rays which are coming from cathode, so that the rays are called as cathode rays. So what? So what, children? What happened? So what are the conclusions we have to take it? Now, Thomson came to explain with series of gases and to find out at the special condition of 0.001 mm of Hg, the rays which are coming from cathode can be called as cathode rays. These cathode rays are giving out some information. Now my point is, by this experiment and by these experiments, William Crookes discovered it, William Crookes, Benjamin Franklin, Michael Faraday, all these are the scientists, they came forward to explain the concept of electric discharge or discharge of gases. They came to give some ideas actually. But Thomson came to conclude that, hello, what Dalton said, that Dalton explained atom is indivisible, atom is the smallest particle of the matter, which is wrong. So I want to explain one thing. Thomson refuted the concept of Dalton theory. That is the first point actually. The first point is rejected by Thomson theory, because Thomson explained that is atom is divisible. That is the first point he explained to the society, to the chemistry world. And second point is atom has a negative charged particle. These negative charged particles are moving like a beam from cathode, which are called as cathode rays. All these cathode rays are just like a particle, so that we can call it as the beam of cathode ray is called as electrons. So electron beam is coming out from cathode electrode. So we want to conclude one thing. When when an electrode is fixed to a discharge tube, they came to give a conclusion, that is, when it become ionized, when it gives an electron, give out an electron, we can say there are negative charged particles. There is a negative charge in atom. So we can say that atom is divisible by this experiment. So he refuted the Dalton's first proposition, that is, atom is indivisible. He refuted, and he gave a revolutionary path. He paid a revolutionary path to the further society of chemistry. J.J. Thomson was received and honored with the Nobel Prize. He did a great experiment. That's we will discuss in Thomson's atomic model, how the electrical negative particles are flowing as a beam, and what are the implications also. Do you know cathode rays are used in the glowing of this electrical discharge is used in so many various fields actually. Like advertisement boards are made up of this kind of electric discharge experiments. And CRT, cathode ray tube, is also actually made by this principle, electric discharge principle. So dear friends, we have an ample of observations in order to refute the teaching of Dalton's theory, and give a revolutionary thought for further chemistry students and chemistry aspirants. So the great work of Thomson explains the divisibility of atom. 1895, X-rays were invented. 1898, cathode rays were named as electrons by J.J. Thomson. Children, today I explained you the divisibility of atom. It is possible by the experiment of discharge tube experiment. So this is the experiment. Please look at this experiment and study it. Don't waste your time, and be courageous and study. Thank you so much. Thank you, children. Thank you.